Well, hello again, AB students. Looks like it's time to grade or to score your first three questions here from 2018. So let's go ahead and let's get at it. So interestingly enough, this first question is actually inspired. This is the escalator question. It's actually inspired by the AP Calculus reading. We do a lot of going up and down of elevators between floors at the convention center where we do the reading, and this is what actually led to the lines waiting for the escalators led to this particular question. So let's take a look at it and let's see what it's going on, and let's see how you should be scoring it. All right, so first off, part A is worth 2 points. One is if you get the correct integral. You want to know how many people enter the line, so you've got a rate for people entering, and so the total amount you will integrate from 0 to 300 of your rate function. You don't have to write the r of t, d of t. You can actually write what that rate function is. What you will have to write that what the rate function is when you enter it in your calculator to get your answer, which ends up being 270. So getting the correct integral written down on paper, that's what gets you your first point, and then actually entering it correctly in your calculator and coming up with 270, that's what gets you the second point. So that's what you should have there for part A. If you just have the answer, nothing written down, by the way, that's a 0. Bald answer, 0. All right, part B. So part B, we have to see that now this is asking for at the time of 300, how many people are actually in the line? And there's a number of things that have to be considered. You have to consider how many people are actually it's on the escalator. You have to figure out how many people were on the escalator to start with, how many people have gotten on versus how many people have gotten off. And so you must consider the rate out. That's the new component there. So that you must be subtracting this 0.7. That's the rate that people are getting off the escalator. If you have that and you're considering that, you get 1 point. That's a soft point. Then the hard point is to actually put all of it together. You must add up the number of people that were on to begin with. The integral here representing the people that get on, that's a 270. And then the integral here, which is this rate times the 300, since it's a constant amount, gets you your total of 80. All right, part C is just worth 1 point, just very straightforward, and you have to get your answer. And the first time that there are no people in the line would be at 414.286 or 414.285 seconds. That would be the time at which there are no people in the line. All right, then for part D. Part D is worth 4 points. It's worth quite a few points here. Once again, this is an example of using the candidates test to find, in this case, a minimum number of people in the line. So what we see here is you get 1 point if you consider that in order to figure out the critical points, we must look for where the rate in is equal to the rate out. In other words, where the difference in rates is 0. So if you're considering that, either where r of t is equal to 0.7 or r of t minus 0.7 is 0, either way it can be expressed, that gets you 1 point. If by looking at that you correctly identify this 33.013, that gets you a second point. Now also that should lead you to this one here, but that doesn't happen to be the critical one, so we're not going to worry about whether you get that one at all. If you get this one, you get a second point. Now if you get the correct answers, which are that there's a minimum number of people at a time of 33.013, and there are 4 people in the line, that gets you your third point. Your justification is this chart. It's your candidates test that you know that your minimum has to either be at the beginning, the start of the interval, the end of the interval, in other words, one of the end points, or it must be at a critical point. So what we have done here is we have found the 2 critical points. That's this T1 and T2. And then we've calculated the people, and it turns out T2 is actually a maximum, but T1 is the minimum. Only 4 people on the escalator, approximately 4 people on the escalator at that time, whereas the endpoints are 20 and 80. We've already figured those out. Well, 20 we were given, 80 we figured out. And so our answer is that it is at a time of the 33.013, and there are 4 people in line. All right. So score that out of 9, and let's go to question 2. So question 2, part A, is just a simple, it's a 1-point question. You must simply take the derivative of the velocity at the value of 3. That's it with your calculator, and you get that the acceleration is that negative 2.118. All right, pretty straightforward. Part B, so you get 1 point if we can see that you did take the integral going from 0 to 3 of the velocity function. Now you can write out the function for velocity. You don't have to leave it as the v of t. You can actually write the function there. But you must be integrating that. You must have the correct limits of integration. That gets you 1 point. You get another point if you knew to start with -5 and add that to it, since the position when x is at 0 is -5. And then if you combine it all correctly, enter it correctly in your calculator, and get the final value of -1.760, you get your 3rd point. All right, part C. So part C, you have 1 point for your answers. And your answers here are these, 2.844 and 3.737. You can't get half point if you get one right and not the other one. It's one of those where it's all or nothing. You either have them both and you get a point, or if you have 1 or 0, you get no points. Then for part 3, now you get your interpretations. It is 1 point for each interpretation. This one you must say is the displacement of the particle over the time interval from 0 to 3.5, and this one is the total distance from 0 to 3.5. If you don't say 0 to 3.5, you do lose one of the 2 points. Okay, it doesn't matter if you don't say it in both of them, you'd only lose one of the 2 points. All right, part D. Part D, first we need to see in some expression that you knew to take and look for where the velocity was equal to the derivative of x of 2. Okay, need to see that expressed somewhere. Then when you solve that, you should get a time of 1.570, and or you could write 571, either way, truncate or round. And so that gets you your answer point. All right, score that out of 9. And let's move on to number 3. Number 3, we are evaluating from the graph. So for number 3, first for part A is worth 2 points. 1 point is for the integral, which could either be in this form here, 1 to -5 of g of x dx, or you could have a negative in front and go from -5 to 1 of g of x dx. Either this with a negative going from -5 to 1, or this going from 1 to -5 gets you your integral point. And then if you know how to combine it correctly with your initial value of 3, do all your evaluation, and get to the correct answer, you get your answer point, which is either 25/2, or if you left it like this, that's okay. But it must simplify to 25/2. Okay, part B. First, if you recognize you must split it at the value x equal to 3, that there are different functions between 1 and 3, and then 3 and 6. So if you indicate that you recognize you have to split it there into 2 separate integrals, you get 1 point. That's a soft point. Pretty easy to get that one. Then if you do the correct antiderivative here, which is found in these brackets here, getting this 2/3 times x minus 4 cubed, that gets you a 2nd point. And then if you actually use your initial value, evaluate these things correctly. Actually, I said initial value. That's the value of this integral here. Evaluate with the correct limits and get to 10. That gets you your answer point. All right, part C. Part C, 1 point for getting the correct intervals. 0 to 1, 4 to 6. That's an all or nothing point. You've got to have both intervals or you don't get it. And your reasoning, somewhere you must indicate the relationship between that f prime is equal to g. We need to see that either on this one or on this one. If it's not expressed in either one, you will lose your reasoning point for this one here. So we need to see that relationship, and we know that it's because it is our g of x is increasing on those intervals. It's positive and increasing. We have to say both. Our g of x is positive and increasing on those intervals. And for part D, you get 1 point for your answer. There's an inflection point at x equal to 4. And your reasoning is because g of x changes from decreasing to increasing at x equal to 4. Okay, so that would be what you would have there. Score that out of 9. Score the whole thing out of 27. Take a picture and turn it in. And we'll be back with another video tomorrow.